Cool. All right. So, good evening, everyone. As you all know by now, my name's Kyle. For my master's capstone project, I decided to take a deep dive into the world of Smogon tiering and predictive modeling. So, for a brief history, first, this is the abstract I did for my paper. You don't need to read all of it. I'm not going to read it all for right now. But the project is essentially going to look into Smogon's tiering system and attempt to dissect it beyond the basic requirements that Smogon currently uses for tiering, in order to gain some insight at what is at the core of each tier, as well as to see how a predictive model can compare to a human. Don't have high hopes for that second one though. So for a quick brief history, I'm sure the three, I think, that are in here right now, two that are in here, already know most of this, but especially for the professor and for anybody else who might watch this in the future. Um, Pokemon is a global phenomenon. It's a video game that was released in 1996. As of I believe current, they have sold over 480 million games or versions of the game. The main goal is to capture creatures, which are known as Pokemon, um, train them to battle, and get even stronger. However, even with the amount of sales that they have, a lot of players opt to do online battle simulators. So the most common popular one right now is called Pokemon Showdown. And what that does is it allows a lot more team customization, um, reduced entry to be competitive in the format, and a whole host of other reasons that people choose to play it. An example of popularity on Showdown in just one format in the game modes, which is Gen 9 OU. We'll get into what OU means in a bit. There was over 1 million battles in just July of this year, and that's one format. Showdown has, I believe, around 100 formats on it. Gen 9 OU is one of the most popular, but that's still a pretty good sample of how widely used this is. So around 2004, Smogon, which is the forums page for Pokemon, was first created. Before this, players were just working with each other through like game facts and other forums that were just generalized for gaming, and rather than being specifically for Pokemon. Smogon gets its name for the German name for coughing. Coughing is the little funny guy in the bottom left. The German name for him is Smogon. They took that as their name, and it is currently the largest unofficial Pokemon tiering source. It's the largest overall, unless you consider Pokemon's own tiering system, which is a very basic banned, not banned, and restricted. Those are somewhat self-explanatory. The Pokemon have some restrictions. They can't be used or they can be used freely. So Smogon has 9 tiers total if you include ZU, which is an unofficial tier, and subcategories of those that are listed as like ban lists. Those are not going to be super relevant for this. For those, I just considered it to be the tier above because it can't be used in the tier for the ban list. The 9 tiers are Ubers, overused or OU, underused or UU, rarely used or RU, never used or PU or NU, PU, which is not an abbreviation for anything. ZU, which is the unofficial tier, it's listed on Showdown. So I decided to use it for this, but technically, from what I understand, it doesn't exist. Finch, feel absolutely free to correct me on that. Um, Not fully evolved or NFE, and then Little Cup or LC. So in general, OU to ZU are the general tiers, the main tiers. They have a 4.52% cutoff for whether Pokemon rises or drops. So for example, if coughing had 4.52% usage in OU, it would be considered an OU Pokemon. If it was already in OU and then dropped below that 4.52, it would drop to UU. And so that's generally how these work. The exceptions to these are, well, not really exceptions to this for the first two, but LC and NFE are special categories that are for Pokemon that have not fully evolved yet. So evolution is a mechanic in the game where Pokemon can turn into a stronger Pokemon as it gets stronger. So coughing over here would become a Pokemon known as Wheezing. Um, and Wheezing would not be able to be an NFE or LC. That's important for what you're about to see on the next page. Um, Uber
So,
essentially acts like a ban list for OU. So if a Pokemon is too good for OU, slapped in Ubers. Uh, that is the only ban list that we will be actively discussing because it is the one of the largest tier lists. It's considered an actual tier rather than like a subcategory. Um, so it's just one of those that's kind of important. Um, so that's
so how long have you been playing this?
me personally,
Yeah.
since I was like three. Not competitively. I've been playing the video game since I was like three. I started playing like on Pokemon Showdown and stuff like that back in 2014, I think 2013.
Wow. Okay.
Uh, and Josh did say ZU is an unofficial tier, but is played regularly on Pokemon Showdown. Yes, thank you. Um, So now I'm not going to go over all of these. This is my quick research into previous attempts. None of them have been very good or super in depth. So officially, I believe this is the first that goes more in depth than just having crappy models. Um, but two of them,
So,
sorry, go ahead.
so these are predictive model attempts. What are they trying to predict?
So yes, they are trying to predict what tier a Pokemon will be in given different um variables. So that I will kind of go over that as we,
Okay.
but because that's something that I'm trying to do as well. These guys are just bad at it. The first one never even did it. He said it was unsuitable after doing like maybe 2 days worth of exploratory data analysis. And the last one gave up after telling the other three that they're bad at their jobs.
There you
So,
go.
so
So what is the value? What do, let's say you build a good predictive model,
okay.
what is the benefit to mankind and the benefit to Kyle in building a good predictive model? What does that give you
So
as in terms of an edge in the game?
So, in terms of the game itself, I wouldn't say there's much, but in terms of more so, as new Pokemon are released, there's always a scramble for trying to figure out what tier they should go in. Um, and a lot of movement. I mean, again, uh, Josh can definitely confirm that for the first, what, 6 months, 7 months that a game comes out, every single month there's masses of Pokemon moving up and down in the tiers. Um, so it's a very dynamic system. And so as such, being able to create a predictive model that can do it with honestly any reasonable accuracy is already a step up from where we've been at, which is just kind of wait and see what happens.
And what's the benefit of that then? If you can slot one better than kind of this iterative approach, what advantage does that give you?
Yeah, so if you're able to theoretically, if you're able to start a Pokemon in a tier that it is predicted to be in rather than just starting them all in one tier and moving them as you go. It
Yeah.
will take time off of how long it takes um for the meta game for the game to like uh to smooth out like to kind of reach the reasonable tiers. So that goes back to what I was saying before. Right now it takes 6, 7, 8 months for correct. The guessing game, every release is infamous in the community and tens of thousands of people participate in it. So yeah, so it's one of those things where right now with the iterative process, it's 6, 7, 8 months. If you had a beginning placement for the tiers, you would be able to cut that time down because a lot of the Pokemon will already be in the tiers they're supposed to be in.
Okay.
And of course, that still doesn't always work because every 3 months there's still some changes, but it's a lot less than the first beginning couple months.
Okay.
Um, so for this project, I created my own data set, um, lots of independent variables. So I know it's a little scary for me too. So 57, there was 62 total independent variables. So an independent variable is just what you're going to use to describe the response. So in this case, we're trying to determine tiers. These are how we're going to try to determine it. These are just data points for it. So there's 57 objective. If I go through all of them right now, I will waste the 25 minutes I have. So I'm not going to do that. The important ones for later on are stats. So stats, there's six of them total. Each Pokemon has six stats. There are health, attack, defense, special attack, special defense, and speed. They all kind of do exactly what they sound like. Health is how much health your Pokemon has. Speed is how fast it moves in its turn. Attack and special attack are basically, it's easier to think of it as physical versus special hits. So there's a move called Confusion, for example, that's a special attack. It attacks your Pokemon's mind, their psyche. And then there's Mega Punch. I'm sure you can guess what that one does. So, um, and then defense and special defense are the same thing, just on the defensive side rather than the offensive side. Um, there's four group subjective variables. So this essentially just means that I determine the best way to handle a couple of the variables, which were abilities and types. Each Pokemon has between 1 and 3 abilities that just give it a additional benefit. And each Pokemon also has a type. There's a whole type chart. I should have put it on here just to confuse you even more, Professor, but it's very big. There's 18 types. Each Pokemon can have at least two, at most two types. Lots of combinations. But so the best way I determined to evaluate those were to ask players who are good at the game, high in Smogon's system, or just generally considered good, to rank the abilities, and then I or and type, uh, and I used the average of those numbers as the rating for how good the ability or type is for the Pokemon overall. There was also one individual subjective variable that was just whether a Pokemon hits on the physical side, the special side, or a mix of both. I did that myself using the Smogon's suggested move sets, like the attacks that they suggest, as well as just my own knowledge of the game. Sure, some of them are wrong, but most of them should be correct, mostly. Um, oh, there was 861 observations total, so that's how many Pokemon are in the current metagame. And most of the collinearity or the correlation between the variables was low, so there's not much interference or noise between them, except for stats, and that's kind of makes sense. I mean, if you have a high HP stat, you're more than likely going to be a stronger Pokemon, so you're more than likely going to have higher stats otherwise. There's some Pokemon that break that, but that's a general idea of how you should picture it.
You had back in the day when you started this, you had, and I can't remember, you had more than 62 or something, and
I had 83.
you were working on calling the herd there a little bit.
Yeah, I had 83.
Yeah,
Um,
yeah.
now I have 62, and we're
Okay, that's
happy about
something.
62.
Yeah, yeah, yeah. That's okay.
So the two objectives I have here, I've mentioned them before. The first one is to try to create an analytical model that can predict Pokemon tiers better than an average player. So as I mentioned, and as Josh confirmed, there is basically a huge guessing game when new Pokemon come into the games of where they're going to be. So my model was going to try to see if it can do better. I'll explain a little bit how I tested that later. The second one is to just evaluate what variables end up being most important for the individual tiers. Immediately, I'm sure the people in here can guess already, but I had my own presumptions and it turned out I was right. So again, we'll get to that one later. If you want to guess, feel free. um, just guess the top 10. Um, so this is more for the, sorry, go ahead.
So the go back a slide. So you have a model here.
Mhm.
You want to know if you can predict better than the average player. So you have a metric for how an average player does. Is that a fair
Kind of.
statement?
It's yes and no. So the average player, I think, was an overestimate on my side for who I actually ended up asking to compare to. I think the people I asked to compare against are a lot better than what I would consider the average player.
Okay.
So when we get there, you'll see. But
Okay. Okay.
spoilers, my models got blown out of the water. It was not close. But it still performed better than a different metric that I had, which you'll see in a minute.
Okay. Well, there is no failure in this. Every every wall that you hit is something that you've learned, and so
Yeah,
there won't be we've talked about this before, in general, that there are no there are no bad models, no bad results. It's just we've learned something and now we pivot a little bit to
Yeah. Um, okay, so this is more so just for the professor to see, but essentially, I did a couple things for processing the data. The first one is that I split it into a test and a training data set. And that's exactly what it sounds like. So I took the total data set, I took some of them. In this case, I took I think it was two, yeah, it says there 215, and I just kind of set them aside. So they're not part of building the model in any way. They're there just for comparison to see how the model does against this data set. And that's to help avoid overfitting. You don't want the data in the model because then the model will actively have those as a reference for when it's trying to predict where it is. It's basically a feedback loop. Not good. So we did that. And I also did cross validation. It, from what I understand, Professor, correct me if I'm wrong, but from what I understand, it's essentially the same thing as training and testing data set, just on just the training data set, and it does it a bunch of times and then determines the best out of those
right.
just to build the model itself.
Right. Out of that then comes the given the cross validation, you essentially take an average
Yeah.
in the calculations. And the whole idea is to smooth out potential extreme values, and it leads to more consistent estimates, better estimates. All right, very good. You're able to do both, and you got a reasonable data set. So very
So
good.
now here's the fun part, and where I made way too much work for myself. About a day after finishing my original art code, I went, hey, I should look into this. So I redid everything. But so in data science and data analytics, there's an idea of what's called a class imbalance. So that's when, for example, if you look at the base list, you can see these are the reference of how many Pokemon are in each tier in the training data set. So if you look at it, you might immediately notice, hey, LC has 164 Pokemon compared to OU's 37. So, in general, the models will be more trained to accurately get the LC than the OU because that's a larger data set. So it skews the data basically. So the two methods to handle it, besides just leaving it as is, which I also did to compare them, is to oversample, which is essentially when you take the existing data and just kind of artificially inflate it so that way they're a lot closer to the same numbers. So for example, OU now has 111, 70 some of those are not real Pokemon or are duplicated, stuff like that. Undersampling, the exact opposite. You kind of cut ones randomly or semi-randomly, I believe, to try to make them all again around the same number. In both of them, you kind of lose some niche knowledge of the data by overinflating or cutting them out. But at the same time, it can still offer a much better insight in terms of the models. So,
Yeah, particularly when you're evaluating them against a test data set,
well,
that's where the real value comes in.
yeah. So I'm
Okay,
not
good, good.
again, I'm not going to go over all this, but these are the different models I chose to look at. You can see very simplistic benefit and detriment for all of them. Um, the general idea is some of these are good at dealing with class imbalance. Some of these are good at dealing with overfitting. Some are good at ignoring like noise, which is just unnecessary data that's just kind of bogging everything down. Um, so that's kind of where I opted to choose these. I'm gonna give another spoiler here. Bottom left one, I think I did something wrong every single time I used it. It sucks. I would never use it again. I don't think I've ever, even in the actual classes, I don't think I've ever gotten a good accuracy or any model on neural network. But
And it takes forever to run.
yeah, so
So okay, no, that's fine. So is it the case that we have how many groups we have?
nine.
Nine classes. Yeah, okay,
Yes.
okay. No, that's a I think that would be a tough model for a neural network
Yeah.
to I think it's a tough model for it. Okay, very good, very good. Yeah, it
So
is a challenge with nine groups.
yeah, so here is where understanding the results comes in. So Um, I'm gonna try to explain this very simply, just because I can already tell. I mean, even for me, this kind of gets a little muddied. So there's a couple different ways to measure the how well a model does. The two that we're gonna immediately look at are called accuracy and F1 score, but we're not just looking at those. We're looking at what I call generous accuracy. I'm sure it exists somewhere, but I've never seen it, and a weighted F1 score. So accuracy. We're gonna for this one, we're gonna look at the top right. I should have moved them a little bit further apart, but the top right table with the apples, bananas, and steak. So for accuracy, it looks at how many you got correct versus how many total predictions there are. So in this case, we had five apple. Let's look at prediction A. We had four apples, six bananas, five steaks. So that would be four, five, and five that we got correct. That's 14 out of 15. Yes, that's how that math works. So the accuracy would be 14 out of 15. Generous accuracy, what it does is it essentially gives a smaller bonus point almost for getting close to the correct answer. So, for example, in prediction A, because there was an extra banana and bananas are closer to apples than steaks are, it got, I mean, as far as I know, but because bananas are closer to apples than steaks are, it guessed the banana on one of the apples. So it gave it a little bit of an extra bonus for that, but it not as much as getting the apples correct. I believe in my model, I did about a 1 to 3 ratio. So for every 3 points, the actual guess is a close guess is 1 point. And the idea for this is, especially with how dynamic the tiers are, it was to benefit. Um, it might, for example, guess that a Pokemon is in OU and it's not an OU, but then in 2 months it becomes OU. Like models can change like, or the data can change like that dynamically. And so it kind of gives it benefit of the doubt there. And then along with that, it also helps with what I mentioned briefly before, ban lists. So there are some things called ban lists where a Pokemon is in UU, it is absolutely dominating the tier, and so they ban it from UU. It can no longer be used, but it doesn't hit that 4.52% usage in OU. So it can't be OU either. So it's called UUBL or UU ban list. I think at some point it was called UU borderline, but UU ban list. Um, so for this, we're essentially calling it OU because that's the first tier it can be used in, but it still has the same relative stats and stuff as Pokemon that would likely be in UU. Um, so it kind of gives leeway for both of those. The F1 score, a little bit more niche. So essentially what it does, it looks at a combination of how well the model manages to correctly capture all the correct information, as well as how often it over predicts information. So the bottom right table with the cancer and not cancer has the formula for an F1 score, and a little sample there. TP means true positive, so that's when it thinks it's cancer and it is. FP is false positive, when it thinks it's cancer and it's not. When it false negative, FN, when it is cancer and it says it's not. And then not cancer, not cancer, true negative. Doesn't matter for the sake of that one score. Um, but yeah, so it essentially compares how well it guessed everything, how many it got correct versus how many it over predicted and how many were in the tier that it did not guess. It's like I said, a little bit more advanced. Um, the weighted F1 score, same thing, just it also compares it with the class imbalances. So, for example, OU had 37, or I believe, so it would take that into account um, in the formula um, when it takes the average for the F1 score across all of the tiers.
Okay,
Um,
so the true positive. So example, if we look at the F1 score, the true positive, that is summing up the true positives across all 9 categories. Is
Kind
that how we want to interpret each true positive, true negative,
so
false positive, false
this
negative?
this specifically in the bottom right was just an example for F1 score on a two class classification model. I have
Okay.
in the actual paper a little bit of a better, it stands for both bandless and I have in the paper a little bit better um the full definition of what it is, but it's essentially
Okay.
the average of the F1 scores for each tier individually, but are before it's summed up or averaged, it is divided by the weight of the class. So how many
Ah, okay.
so
Yeah,
it's
yeah.
yes.
So it's a weighted average. Okay.
Yeah, weighted average.
The so the goal here of going down this path instead of relying on accuracy, because you've gone beyond a two-class model, this is your attempt to um, try to account for differences in accuracies across the different classes rather than just lumping them all together in one big number.
Yes, exactly. So
Is that it?
something
Okay.
yeah, so something I learned in the previous modeling attempts that I was looking at, and something that Mitchell Newman, especially the last person, really focused on, is accuracy is a very bad metric for something like this with the class imbalance and how dynamic the tiers are. And so this is my attempt at trying to still utilize accuracy, but trying to account for those issues. Um, because I still think in general accuracy is a very easy to understand metric. And so for the sense of something like this, I want to try to keep it implemented.
Yeah, and it's certainly a good starting point in a deeper research or deeper analysis of the data. It's certainly a good starting point for wherever you're going.
Thank you.
So, all right, very good,
If
very
I ever
good.
get there, thank
Now,
you.
yeah, the the other researchers that you looked at, whose work that you reviewed, did they go down this path in any way?
Um, so the first, I'm actually going to go back to that slide real quick. Nicholas never actually even created the model. Like I said,
Okay,
the exact quote was unsuitable for machine learning, which I think is
there you
wrong,
go.
obviously, or else I wouldn't have
Yeah,
continued the project.
throw up your arms and move on.
Mitchell Newman,
Okay,
at the end, also never actually, I don't think he even started the project. He did an analysis of the other three and then ended it with, in the next post, I will do my model. And there was no next post. Um, but Devin and Dylan both used just accuracy. And at one point, they even managed to get 100% accuracy on one of theirs. But they had a number of different problems. Like they had a very small data set. They think it was due to overfitting because they didn't have a training and testing data set. Whole bunch of different reasons.
okay,
And then
yeah,
Portho,
okay,
I don't, I think he used just accuracy as well. So,
okay, very good.
uh,
So you're extending the literature then.
a little bit, yeah. So here is the model results. Sorry if that's a little hard to read. I didn't think it would be that difficult. The important ones here are the red highlighted ones are the worst, and the green highlighted ones are the best. You can see, uh, so in order, it's weighted F1, generous accuracy, weighted F1, generous accuracy, and it's by base, oversample, and undersample. All three of the data sets. Um, so all of these kind of make sense, which with what I thought was going to happen. So LDA and well, LDA or linear discriminant analysis, especially, is very good for class imbalances. Um, so it doesn't really surprise me that it was one of the best performing for base, for example. All of the others kind of have a similar idea where bagged and boosted forests are very good in those senses, for oversampling and undersampling. So it makes sense those perform the best. Like I said, neural net sucked. Never using it again. The only one that it didn't score the worst
Yeah,
in is the undersample for conditional inference trees. I It still didn't perform that. So yeah, that was not good. Um, so for tuning,
okay,
so after getting these models, those were all based on a very basic running of the models. So no real like arguments or parameters given into the models outside of the basic ones that everything got. So here you can see the four different models that performed the best and the tuning I did for them. So, and you can see the increase, well, not the increase, you can see the new accuracy and or generous accuracy and weighted F1. Um, because overall linear discriminant analysis, its scores were generally, I think, better than random forest. I mean, the generous accuracy is a little bit better, but it's like 0.003 versus the 0.034 drop
Yeah,
in weight. So
yeah,
I
yeah.
decided to keep linear discriminant analysis for the future. So the bottom three here are what's going to be kept for comparisons.
Yep. Rely on Occam's razor
Yeah.
for doing these kinds of things. So very good.
So now we're on
All
to
right,
the
good.
objective one. So objective one, before I say this, the BBA I'm about to explain is actually more so for objective two, for just a point I was going to make, but I figured I would mention it here first because it's going to show up in objective one. So in order to evaluate these against other models, I created one comparison method, and then I had the competitive player analysis. So for the BBA basic BST analysis, BST is just base stat total. So that is what all of the stats together equal. It's just the sum of stats. So what I did for that is I took the average of the base stat total for each tier, used that as a baseline, rounded the test data Pokemon's BST to those numbers. Whatever it was closest to, that's the tier it got lumped in. So it's a very, very basic model where it just looks at stats to see where they think it should go. So if a Pokemon has 300 BST and LC's 295, it'll go to LC. Um, so it kind of, like I said, it just rounds it to those tiers. Super basic model. Um, and then competitive player analysis. So I asked four people total. Ethan, who's in the call, Ryan, who's not, Josh, who's not, and then Connor, who's not. But I asked them all to uh, take the test data set, gave them just the Pokemon in the test data set, said, hey, based on this information, guess what tier it is. I did give them access to the training data set because so did the model. So it makes sense, I think, to give them access to that. Um, so the idea was to compare to their results how my models did. And as you'll see on the very next page, I got completely blown out of the water, like I said at the beginning. I mean, even the worst player, which was in this case Sawt or Connor, whichever one you want to call him by, outperformed my best model. And again, it wasn't even really close. I mean, it's 0.07 and 0.05. Um, and that's not even to get to Yayan at the bottom, who did zero point 0.2 and zero point 0.2. Um,
So how did the humans come up with
so
their
that's
measures?
that's something more so for them to actually explain. Like I said, Ethan was one of the ones I asked. I asked people who were not in like invested into Smogon's tier system, but are just good at Pokemon generally. But so I don't know exactly like their thought process for all of them, but I'm sure they used a combination of their knowledge of the game, the data in the training data set, um, and then the testing compare like the stats and stuff that are in the testing data set. And like I said, they blew it out of the water. Which
Well,
goes
I mean, it boils down to you said that it blew you out of the water, but we don't really know how they came up with what they came up with. Um, so I think that's important to understand. I mean, you could toss a dice or toss a coin and make decisions that way. Now, these are presumably not modelers in some sense. So how would they take 62 variables with a test data set and a training data set and come up with a measure of accuracy that somehow blew blew you out of the water?
So again, and this is something I can't really speak to exactly how they interpreted it. My guess is that they took a look at the stats, they looked at other Pokemon that are similar in nature, even if they don't necessarily show to be similar in the actual data. So for example, a very, very easy example, there's a Pokemon that's called Arceus. It is an Ubers level Pokemon, it is in Ubers, and it has 18 different types. And all these types are listed separately in the data set. So if five of them are in the test data set and 13 of them are in the training data set, they can look at the training data set, say, oh, these 13 Arceus are Ubers. So these five are probably, so I think it's a combination of pattern recognition as well as, like I said, just general knowledge of the game. Even if they don't necessarily know the tiers, they know, um, like relative to other Pokemon, how good Pokemon are, which is something the model can't really have intuitively in it. It has to kind of try to build that by itself. Whereas they have a background of playing Pokemon for years, which goes to what I said at the very beginning. I don't think, in hindsight, I don't think these four were the best to ask. They're very good at the game, so they kind of already have, I think, more than what the average player would have in terms of knowledge of the game beyond just what was in the testing data set itself.
Okay. So something to think about. The doctors do um, they'll look at various tests results, MRIs and CAT scans and all sorts of tests, and they make their best guess
Hmm.
as to the situation for a patient, and over time they develop a real expertise in being able to identify whether or not uh, this patient has a disease or not. And yet today, it's taken a few years, but today you can build models that do a better job than doctors with
Hmm.
decades of experience. So the question is then, is your model just not have caught up to the doctors
Yeah.
and their expertise? And so this could lead to some additional avenues of research to understand um, what is it that the humans are bringing to the table that the machine can't capture in this particular instance, because in medicine, certainly in many fields, machine modeling is starting to outperform humans. So just something to think about.
Yeah, and that is something, at the very end, I think I have a quick page that's just things that I think I did wrong or could have done better. And that is kind of
Yeah,
included in there, in that
good.
there's hundreds of variables that I could have included. Like that 87 or whatever I had originally, that was already a
Yeah.
very watered down version of how many variables there could have been.
Okay.
So,
Yeah. Yeah. Yeah.
that's another part of it, is that this just physically putting every single variable is, it can work. It shouldn't.
Yeah. Yeah.
So,
Yeah.
it was very challenging to try to figure out exactly what variables to keep, what not to keep, what I think would be important versus what the
Sure.
model will actually be important. Um, but
Yeah, feature
uh,
selection. Feature
yeah.
selection is can be tedious and time consuming and
Mhm.
over an 8 week period, tough to be as thorough as you
Um,
might like. But
I didn't.
well, you take the go ahead.
I was gonna say I didn't fully go into it on here. You'll see it in the paper when you get that far. But I did also do feature selection. I did Boruta testing and near zero variance. I did a combination of both on all three data sets. I have a list of everything that
Yeah,
got. Actually, no, I don't think it's on here. It might be. I don't think it is. Sorry, it's been a while since I looked at some of these slides. But uh, it was a comparison of uh, each data set itself as well to see what got removed and what didn't. So I also have stuff like
yeah,
that in the background, but I'm sure there's
good,
other
good.
feature selections that would have done better as well.
Okay, good, good.
The
Well, I mean, you took a stab at it, and that's the important thing.
the other very important thing here, and this is going to get more important in the very next slide where I go over the variable analysis. If you look at the BBA model, the basic BST analysis, it performed the worst, but not by that much. And
Hmm.
that immediately makes me wonder how, well, not wonder, but it kind of confirmed my original thought that stats are going to play a huge role in what tier Pokemon is, what tier Pokemon is in. And as you'll see on the next page, yeah, so here's the variable analysis. So this is after I ran the models, this is what each of the three best models thought the importance of everything is. These are out of 100, where 100 is whatever the highest is. It's variable. So if something is 95.22, that means compared to, for example, the HP stat of 100, that means compared to HP, it's 95% important, from what I understand. So you can
Yep,
see
you're absolutely right.
all three here. you'll see the very first six data point or variables are the stats. HP or health, defense, speed, special attack, special defense across all six. So that
Yeah,
kind of explains how the BBA model did so well. Because I mean, even these are all agreeing that those are incredibly important. Um,
right.
and then generally, except for LDA, the next four are going to be the subjective models that I had people, the subjective variables I had people rate the abilities and typings on. So offensive, defensive, and utility rating are the type ratings. Again, I kind of go into that more in the paper, but I essentially broke it down into three types, three categories because a type might have a good benefit offensively and crappy one defensively. So being able to see both of them is a better way than just saying, "Hey, overall, what do you now analyze this as?" Um, and then after those three or three slash four, it kind of drops off dramatically,
Right.
which
Right.
again kind of goes into an error I made in that, for example, let's say Calm Mind. So if you see bagged importance variables, the one right below ability rating is Calm Mind. That is a move that Pokemon learn that boosts their special attack and special defense by one stage or one plus one, so times 1.5, right? So it's a huge buff. The thing is, in my data analysis or my data setup, I didn't take into account whether the Pokemon use special attacks often for the actual moves that they learned. So any physical Pokemon that had Calm Mind were still listed as using Calm Mind, even though it boosts special attacks and special defense. So that's kind of an oversight on my side. But it is what it is. Uh, so
Well,
the
this is good. I mean, you're always going to hit, we talked about it earlier. You're always going to hit, go down blind alleys and hit walls. So
yeah.
it's good. I mean, this is really an introductory assessment, and you realize issues you'd like to explore further. So no, nothing to be sorry about. It's a good first step in terms of where you're at and things that you would change. So it's good.
Mhm. So here's the second part of my variable analysis. So this is just a very quick graph of um, well, average ability, ability average by tier, ability variance by tier, and BST by tier. So, um, ability average is just that 0 to 9 number I had people rate the abilities on, where the average of those are. You'll see there's very little variance, which is why it then surprises me that back on the previous slide, ability rating was so high. Well, comparatively to stats, it surprised me. But then when you look at the variance instead, the second graph, you'll see outside of UU, I don't know what's going on with that one, why it has 2.85 variance. But outside of that, generally, as the tiers get lower in the totem pole, as it were, they have a higher variance of of their abilities. So the lower the tier, the more likely they have a wider range of abilities, um, which also means that they have a wider range of bad abilities. Um,
Yeah, yeah, yeah.
so, and then the third one is the BST by tier. This is just kind of a good way to see how the BBA model was created. So all of these averages are kind of where the model would have based the guesses off of. So whichever one of these averages it rounded closest to or was closest to is where it would put the Pokemon in the tier. So seeing the gap between Uber and OU, for example, and then the gap between ZU and NFE kind of shows just how tight some of these are in terms of their averages, and yet the model still performed that well with this situation. Um, so here's the last one I said, the changes and errors. These are the main ones I immediately noticed. So LC and NFE, as I mentioned very early on, they're only for Pokemon that can evolve. And so as such, they kind of, even with all the overfitting adjustments and stuff like that, it likely still happened because of uh how many there are. And this is something that Portho, one of the people who first tried this, actually experienced. When he built his second model, which was still bad, he only had three tiers to choose from, which was basically OU and above, ZU to UU, and then NFE and LC. But then he also had a variable that was whether the Pokemon can evolve. So basically, he had a one-to-one correlation for one of his tiers of whether a Pokemon can evolve and whether it's in a tier of Pokemon that can evolve. So that by itself had the overfitting there. And then not overfitting, but that by itself had a very high like correlation there. And then the other two tiers were just kind of how high the Pokemon's base stat total was. So even with this, I think that still happened to a much lesser extent in my model. Um, and then the others, reworking neural net, like I said, I wanted to give it another chance. It did not do well. I still want to give it another try, but not right now. It hurt my heart. Um, CPA,
Yeah,
the
and sometimes, yeah, neural nets are sometimes prone to, if you can expand the grid search in some
yeah.
fashion, or increase the number of iterations,
Mhm.
um, it can lead to sometimes dramatic improvements. When we reviewed the concrete data set originally, um, and we doubled or tripled, I can't remember the number of iterations.
Mhm.
I mean, you could take the accuracy from or improve the R squared from 60% to 90%. It was pretty dramatic. So, yeah, sometimes neural network, you got to nudge it a little bit to make it to improve its results. But of course, you're spending a lot more time because it does chew up a lot of computation in
Yeah.
doing so. But I didn't mean to hold you up here. Go right ahead.
No, you're okay. We're almost done, I promise. I know it's already been 40 minutes or something like that. Not even close to the 20 minutes. My
Well,
bad.
for a presentation like this, it's well worth it.
Okay. That's a good sign for my grade, guys. So CPA, so CPA, the player analysis. As I mentioned before, I don't think it was a great sample for the average player to start with. These people are players who have been playing for years, and even if they don't necessarily actively play in the tier system, they still have been exposed to it for all of those years, whether directly, indirectly, whatever. A perfect example of this, Yayan, the one that performed the best, he doesn't have a lot of knowledge in the system itself, but he has a lot of knowledge in the Pokemon's tier system, like the official one that Pokemon runs, the banned, not banned, restricted, because he plays a lot of official game modes of Pokemon on the DS itself or the game itself. So that, for example, I don't think that's a very good example of average player. Um, but so I think if I was to come back to this, I would want a wider range, and then I would want to condense their average into an actual average of how they did rather than individualize it. Um, but that's just one example of what I would want to do. There's a couple other ideas, but yeah. And then the variables themselves, like I said, external fact. So the first one, not all factors could be considered. Each Pokemon learns between 50 and 200 moves. So the fact that I kept it to 62 by itself and it was already a struggle, like I said before. And that's not considering all of the other external factors like whether a move gets boosted by a certain ability or what all that sort of stuff. Along with that, external factors and interactions were likely missed. So, like I said, and the next one, it shouldn't really be a bullet point. It should be one further in. But this is an example. So, setup moves like the one I was talking about, Calm Mind, or another one, Swords Dance. Swords Dance only boosts the attack of the Pokemon. That is completely useless if it doesn't use physical attack. But I still had in the data all the Pokemon that learned it rather than all the Pokemon that would likely use it. Um, so that's something I should have cleaned up better in the data, but I didn't think about it until when I was writing this, and that was
Yesterday.
no, 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 yes, but no, 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 no. Um, so it's stuff like that. But yeah, so that
Well,
is
this is good. This is a good page or a good slide talking about things that you would, because there's a learning process. This is a brand new data set. You put it together. There's going to be a learning process, and so I think this is good that you're showing it like this. I think this is a good example of the analytic process. So so this is good.
So that was the end of the presentation. Luckily, my voice is killing me. Um, does anybody have any questions?
So, so I thought this was a good effort on your part. The uh, I know I know a little bit now about Pokemon.
You
I
gonna start
I,
playing?
I, I, I I suspect I will never get any closer to this. But
Never know.
um, and you clearly are passionate about it, and I liked the attempt to use predictive analytics to help you help provide guidance to you. So no, I thought this was interesting. I thought this was very good. You clearly know a lot about this, and clearly try to take something, take an analytic approach to the tiering, and I think you've learned some things in it. And so when you take this course again, maybe next year, you can bring all that knowledge
Are
to
you telling me I'm failing, so I
a
have to take
sec
it again?
a second draft of this. So no, I thought this was real good because I know we exchanged some notes several months ago about some of the data challenges and all of that. But I think this worked out well. I think this worked out well in the end. In fact, you're able to run all those models. I think is a tribute to what you were able to accomplish. So I think kudos to you for what you did.
Thank you. I didn't mention it on the changes and errors, but something else I would change. My R code, I'm kind of happy that I don't think there was anywhere to submit it. It is so messy. I had to, I did a notebook and I think I ran some things multiple times just because I didn't want to move stuff around to make it make more sense.
Oh, sure,
And
sure,
so
sure.
it's a nightmare.
Yeah. No, it's all good. I've certainly seen my fair share of submissions that are all over the place, and I write code that often is all over the place, particularly, and given what you were trying to accomplish here, when you're doing this and that and the other, and you're trying different things out, it's kind of a natural way to write, to do anything. When you write a book, you're going to be all over the place when you're trying to come up with how you're going to approach an issue. So I
Mhm.
thought that's quite natural, and there's nothing to be. Um, Nothing wrong with that. So good. I mean, you're a good programmer to begin with, and so I think it's all good.
All right. Uh, like I said, does anybody have any questions? Oh, wait, there's chat messages. No questions. I do not have any questions.
Very good. Very good. Well, congratulations. I thought this was most excellent, and I know a little bit more about Pokemon, but I think the idea of how you went through the literature or what others have tried to do, and I feel that you've got something that is beyond what others have been able to accomplish,
Mhm.
and you've established now a foundation, and you can see in this last slide things that you would adjust, and so I think this is a good reflection of a real good understanding of the data analytic process and how it works, and how you were able to explain what you did to an audience that may not be well versed in everything associated with the topic or the analytics themselves. So it was a noble effort on your part.
Thank you. All right.
All right. With that, I think we can, these proceedings are closed. And congratulations on completing the program.